Hi, my name is Charles. I'm the co-founder of Taito Robotics. We're a manufacturer of test equipment for electrical propulsion system. Today I'm going to be talking about the most common failure that you're going to see in the propulsion systems, and I'm going to focus particularly on electrical failures. I'll start with the batteries. An electrical failure of the batteries is probably the most dangerous one that you can have, and that's because of the energy involved. Regardless, whether you're working with a small battery like this one, a bigger battery like this one, or even a very large battery pack like the ones that are used on EVTOLs, you have to have proper safety procedure, and that means having someone on hand that's monitoring the power system, as well as a fire extinguisher that is rated for the type of test that you're doing. Typically what happens with those batteries is that there's going to be some kind of electrical short in them if there's mechanical damage, or if you're doing a test and you're drawing too much current from your battery. What might be happening is that the internal electrical resistance inside the battery causes the battery to heat up, which in turn increases electrical resistance until you have a battery failure, and at that point you're going to see smoke and flames starting. The second kind of failure that you can see happens in the electronic speed controller. The most common thing we're going to see is a failure of a transistor in there. The transistors are used to switch the current to the three phases that we have here, and when the transistor fails, it's the equivalent of a short circuit that causes a lot of heat, and you'll have smoke and maybe a small fire happen. That's usually a bit more manageable than a battery fire, but it can still be dangerous in the wrong conditions. Finally, the other kind of common failure that happens is in the motor itself. Inside the motor, we have coils, and those coils are made of something called magnet wire. Magnet wire is conductive, but the outside has a coating, and that coating has a maximum temperature, which can be anything between 80 degrees Celsius to over 150 degrees Celsius. When it heats up too much, it fails, and at that point you have a short between the coils, which drastically lower the resistance of the coil, and that increases the current, and that produces a runaway where you have a lot of heat, and eventually you have a failure. The failure can be identified visually. For example, in this motor here, we can see that it's a bit darker. That was caused by an overcurrent situation. Or you can also use an ohm meter to identify a difference in the coil resistance. Most multimeters like this one will not work for identifying failure. You have to use a precision multimeter like this one, or you can also use one of our tools, the Series 1580 and Series 1585, as well as measuring torque, current, voltage, thrust, and a few other parameters. They measure the coil resistance. It has a special ohm meter specifically for that reason. So that covers the most common electrical failure that you're going to see in electrical powertrains of drones and electric aircrafts. If you'd like to see more content like this, please don't hesitate to subscribe, and thanks for watching.